Now let's try to find out value of sine theta and cos theta for some standard angles. Now in this picture over here, I have shown 5 distinct positions of point B. For an example, when theta is equal to 0 degrees, that means in position B1, point B is lying on x-axis and its coordinates can be given by 1, 0. In the previous explanation, we have concluded that for every point on a unit circle, its coordinates can be given by cos theta, sine theta. Hence, in this position, when theta is equal to 0 degrees and coordinates of point B are 1, 0, that means cos theta is 1 and sine theta is 0. Now, if we go to theta equals to 90 degrees, that means when point B is in the position B2, which is lying on positive y-axis, its coordinates can be given by 0, 1. That means cos theta is 0, which is nothing but the x coordinate, and sine theta is equal to 1, which is nothing but the y coordinate. In the next position, when theta is equal to 180 degrees, that means in position B3, point B is lying on negative x-axis and its coordinates are given by minus 1, 0. That means the x coordinate is minus 1, which is equal to cos theta, and y coordinate is 0, which is equal to sine theta. For angle theta equals to 270 degrees, point B is in the position B4, which is lying on negative y-axis and its coordinates can be given by 0, minus 1. That means the x coordinate is 0, which is equal to cos theta, and y coordinate is equal to minus 1, which is equal to sine theta. In the next position, when theta becomes equal to 360 degrees or 2 pi, the position B5 coincides with the initial position B1, as we have already discussed. When you move point B such that the new angle can be written as theta plus 2 pi or theta plus n2 pi, sine theta plus n2 pi is equal to sine theta, and cos theta plus n2 pi is equal to cos theta. Hence, in position B5, the coordinates will be exactly same as in B1, that is 1, 0. That means cos theta will be 1 and sine theta is equal to 0. Now over here I have defined a special angle which is written as integer multiple of 360 or integer multiple of 2 pi. Now this angle represents a position which is same as B1 or B5. So for every angle which can be written as integer multiple of 360 degree or integer multiple of 2 pi, the cos theta will become 1 and sine theta will become 0. Now, but there is a question that how do we find out the value of sine theta and cos theta for any intermediate angle? Now, one way of doing this is using the basic geometry and symmetry. So over here I have drawn an equilateral triangle PQR with its sides equal to 1 unit. That means length of PQ equals to length of QR equals to length of PR is equals to 1 unit. Now since in an equilateral triangle all the angles are equal, and we know that sum of angles in a triangle is equal to 180 degree, that gives us each angle as 60 degrees for an equilateral triangle. Now let's draw a perpendicular PM from point P on base QR. From property of an equilateral triangle, we can conclude that the perpendicular drawn on QR will divide QR in equal parts. That means length of QM is equal to length of MR, which is equal to half of length of QR, which is nothing but half, since length of QR is equal to 1. A perpendicular drawn from a vertex to a base or to a side opposite to it also divides the angle in an equilateral triangle. That means angle QPM is equal to half of angle QPR, which is equal to half of 60 degrees. That gives us QPM as 30 degrees. That means this angle over here is 30 degrees. Now if we consider triangle QPM, we can define sine of 30 degrees by using the basic definition of opposite side upon hypotenuse as, so if you look at 30 degree, the opposite side is QM and the hypotenuse is PQ. That means QM upon PQ. Now we know that length of QM is half and length of PQ is equal to 1. So this ratio becomes equal to half, or we can say that sine 30 is equal to half. In order to define cos 30, which is nothing but adjacent side upon hypotenuse, so adjacent side for this angle 30 degree is nothing but PM and the hypotenuse is PQ. So this becomes equal to PM upon PQ. So we need to know the length PM. Now we can find out length PM by using Pythagoras theorem. So square of PM plus square of QM will give us square of PQ. Square of base plus square of height is equal to square of hypotenuse. So therefore PM can be written as root of PQ square minus QM square. Now PQ is 1 and QM is half. So this gives us 1 minus 1 by 4, which is nothing but root of 3 by 4, which can be written as root of 3 by 2. Hence length of PM over here is equals to root 3 by 2. And length of PQ, we know that it is equal to 1. Therefore cos of 30 degree becomes root 3 by 2. We can define sine 60 degree also. So sine 60 will be again opposite side, which is nothing but PM upon hypotenuse, which is nothing but PQ. So we can say sine 60 is equals to PM upon PQ. We know that PM is root 3 by 2 and PQ is equal to 1. So sine 60 becomes root 3 by 2. Cos 60 using the definition becomes adjacent side, which is nothing but QM upon hypotenuse PQ. So we can say cos 60 is adjacent side QM upon hypotenuse PQ, which is nothing but half upon 1, which is nothing but half. So from this exercise we can say for theta equals to 30 degrees and 60 degrees, we can write down the value of cos theta and sin theta. So cos theta, for theta equals to 30 degrees, we have calculated as root 3 by 2. So we can write this as root 3 by 2. Sin 30 we have calculated as half over here. So we can write down sin 30 as half. Cos of 60 we have calculated as half over here, so this becomes half, and sine of 60 we have calculated as root 3 by 2, so this becomes root 3 by 2. We can use similar geometry and we can find out sine and cosine value for some other intermediate angles, but it is very difficult to find out sine and cosine for all other intermediate angles. For an example, if we need to calculate sine of, let's say, 30.3 degrees, then it becomes quite difficult. So we need a different description of sine and cosine function.